Assalamualaikum and a very good afternoon to Encik Hafiz. My name is AB dan ZIKRI and today I will explain to you about lab 1 which is Laplace transform that we learned. Okay, for part 1 which is partial fraction decomposition. I will use question number 3 as an example. Okay, for this question we want to do the partial fraction using MATLAB. Okay, so the first step that we will do is to insert the value of numerator. Okay, so for this question, first step I will put numerator which is 1 and 5 as in s plus 5. So next step is to put the denominator value of the question. So for the question number 3, we will see that the denominator is s the power of 3 minus 3s plus 2. So from that we just put the value of 1, 0, -3 and 2 as in as the power of 3 is 1, while 0 is s power of 2 which is none in the question. -3 is minus 3s and 2 is 2 lah. Okay, after that we will use residue. So for the next step, just type P and K equals to residue. Okay. Okay, so the function of the residue uh, is to convert between partial fraction, expansion and polynomial coefficient. Okay, for this we will convert from polynomial fraction to partial fraction. Okay, if we run, okay, we will see that the command window will show A, which is the numerator of the question, while B is the denominator of the question that we put. Okay, R is our partial fraction numerator, while P is our denominator of partial fraction. So that from the MATLAB, we read the output as 0.333 over s plus 2 minus 0.3333 over s minus 1 plus 2 over s minus 1. Okay. For part 2, which is Laplace transform, I will use question number 2 for the example. Okay, so first step we will so for the first step we will use sim_t. The function of sim is to make a shortcut for the variable. So as you can see in the question, we have variable t. So we will make a shortcut for variable t. So the next step is to copy the question and put it on the MATLAB. For this question, the equation is ft equals to 70. So we just type f equals to 7 times t. Okay, next we will use pretty f. See, the function of pretty f is to make the output more mathematically. If we did not use the pretty, then the output will show the equation lah, but the equation will not tersusun lah. Something like that lah. Okay, so next we want to make the Laplace transformation of the equation. So we will use F besar equals to Laplace F kecil. Okay, from this we know that if we type this, the MATLAB will make a Laplace transformation from the F equation that we type in here. Okay, so after that, we can simplify, but the question is so simple, then I will not do the simplify. Okay, so for the final step, we will make it more mathematically, so we will put printer again, and then we run. Okay, as you can see, this is the output that we will gain, which is 7 over s to the power of 2. Okay, so for the last part, which is inverse Laplace transformation, I will use question number 1 for example. Okay, for your information, part 3 and the part 2 is quite similar step, but instead of we using Laplace, we will using inverse Laplace, which is I Laplace. This function is to transform from the frequency domain to the from the frequency domain to the time domain of the equation. So first step, we will make a shortcut variable like part 2, but in this question we have variable s, so we will make shortcut variable of s. So the next step is we just have to insert all of the equation in the MATLAB. First one. So the next step we will use pretty, uh just same as part 2, and then we will use I Laplace to inverse Laplace the equation of G. And then we will split it again to show the mathematically form, to show the answer more mathematically. So this is the output of the inverse Laplace, which is 2 exponent negative t. Okay, so I think that's all for today. Thank you, sir.